Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2021, paper 1. In this class, we will talk about measurements, kinematics, forces, and momentum. These four topics are very important for paper 1 because in paper 1, you will see about 10 to 15 questions from these topics. So in today's class, we will try to improve our understanding of these topics so you can get better grades in your exam. Let's study together. Let's improve together. In today's class, we are talking about October-November 2021. Total time for this exam is 1 hour and 15 minutes. There are 40 questions on this paper. You need to answer all of them. And the total mark for this paper is 40. On the second page of your exam paper, some data is given. Means values of some constants are given, and maybe you will need some of them for some calculations in paper 1. So if you need any of them, you can come to second page and you can find value of constants. If you go to third page, on third page some important formulae are also given. So let me highlight the formulae you need for AS physics. You need first these two for AS physics, and you can only use these formulae if A is constant. Means they're only valid when A is constant. Mean acceleration has only one value, or simply we can say acceleration is uniform. And the second one is also part of AS physics. And this one you can use when you need to calculate work done by gas or work done on gas. And this one is used when P is constant. So it's important to understand when you can use this one, when P is constant. And delta V is the change in volume. You also need this one for AS physics, and in this formula density, this is density of fluid. So you need to understand what is rho representing. Density of fluid. Fluid means liquid or gas. You also need Doppler effect formula. This formula you can use when the source is approaching, and also you can use this one when the source is moving away. So simply we can say you can use this one when the source is approaching and when the source is moving away. If the source is approaching, then you can use F naught is equal to V over V minus Vs times Fs. And if the source is moving away, then observed frequency will be equal to speed of the wave over speed of the wave plus speed of source time frequency of the source. So plus minus are very important. For AS physics, you also need electric current. And this equation is also called transport equation. So we can write down this is transport equation. These two formulae you also need for AS physics. For resistance, when the resistors are connected in series and resistors are connected in parallel. These are some important formulae you need for AS physics, but these are not all formulae for AS physics. So rest of the formulae you have to remember by yourself, or you need to be able to derive them in your exam. For question number 1, it is given to us a paper book contains 210 sheets of paper. We need to find out what is the average thickness of one sheet of the paper in the book. Thickness of the book we can find from here. So first of all, we can write down thickness of book. Thickness of book, simply we can read this meter rule and we can find out. If you look at this point, this is 0.9 centimeters and this one is 3.6 centimeters. 3.6. So the thickness of the book is 3.6 minus 0.9 centimeters. If we solve this one, we will get 2.7 centimeters, or we can simply write down this is equal to 27 millimeters. We need to find out average thickness of one sheet of paper. Average thickness of one sheet. So we can say one sheet of paper. But we have 210 sheets. Simply we need to divide 27 millimeters by 210. If we divide this one, we will get 0.13 mm. So this is average thickness of one sheet of paper. So the answer for this question is C. For the second question, we need to find out what is the unit of resistance when expressed in SI based units. First of all, we need to understand how we can can calculate resistance? We can calculate resistance using different formulas. One way to calculate resistance is we can use V is equal to IR, and from here we can find R. So R will be equal to V divided by I. We can also calculate resistance by using P is equal to I square times R. From here then we can calculate R. That will be equal to P divided by I square. We can also calculate using energy. Energy is equal to I squared times RT. And from here we can find resistance. So resistance will be equal to E divided by I square times T. I square times T. So we will be using this one. This is very straightforward one. So we can write down resistance is equal to energy over I square times T. Now we need to express E, I, and T in SI base units. I and T, these are SI base quantities, but we need to express energy in terms of SI base units first. For energy, we need to understand energy, there are different forms of energy. We can take any form. SI base units will be the same. For example, if we take mgh, so in this case we can write down kg meter per second square times meter. So we can write down kg meter square per second square. Now we can replace E with its SI base unit, so we can write down kg meter square per second square divided by ampere square times second. Now if we simplify this one, we can write down this is kg meter square and s to the power of -3 and a to the power of -2. Now we can find out our final answer. In this case, you can see D is the right answer. So the answer for this question is D. You can use any approach, you can use any formula. Your final answer will be equal to this. So this is how we can derive. For our third part, we need to find out which list only consists of scalar quantities. If you look at option A, acceleration is vector, displacement is vector, force is a vector, and weight is a vector. So option A is not correct. If we go to B, density is scalar, energy is scalar, frequency is scalar, but velocity is vector. So B is also not correct option. If we go to C, distance is scalar, pressure is scalar, temperature is scalar, time is also scalar. So the answer for this question is C. If we go to option D, momentum is a vector, power is scalar, volume is scalar, wavelength is also scalar. So option D is also incorrect. So the answer for this question is C. Question number 4 is about CRO, and this question is a typical type of question about CRO. You will see this question in almost every paper. So you need to understand how to calculate time period and frequency using CRO. Let's try to understand how we can answer this question. For this question, it is given to us the time base of the CRO is set at 2.0 milliseconds per centimeter. It simply means that 1 centimeter is equal to 2.00 millisecond. Very important point, time base setting. We need to find out frequency of the signal. If you look at this signal, so this is one wave. So this one is one wave. And the time taken is equal to time period. So we can see here, we have 1 centimeter here, and this is second, and this is third, and this one is fourth. In this case, we can simply say time period. This is equal to 4 centimeters. We need to find out time period, so we can say 4 centimeters, and we can multiply this one with time base setting. Time base setting is 2 milliseconds per centimeter. So we can cancel centimeter with centimeter. So we left with time period that is equal to 8 milliseconds. Now simply we can say this is equal to 8.0 times 10 to -3 seconds. For this question, we need to calculate frequency. So simply we can say frequency is equal to 1 over time period. So simply we can say 1 divided by 8 times 10 to -3. And our final answer in this case will be equal to 125 hertz. And this is value of frequency frequency of this given signal. So the answer for this question is 125. For question number 5, it is given to us after measuring the width of a shelf to be 305 mm, it is found that graduations on the ruler used are 1.0% further apart than they should be. We need to find out type of measurement error and we need to find out the true width of the shelf. Let's try to understand what does it mean by graduations on the ruler are 1% further apart than they should be. We have 2 meter rules here. The first one, this one is calibrated. If we take reading with the help of this one, we will get accurate reading. So simply we can say accurate. And the second one, this is first one. And the second meter rule, this is uncalibrated. Mean it has some problem with its scale. So this is uncalibrated. In this case, if we take readings, we will get incorrect readings. Now let's try to understand difference between these two. If you look at the first one, in this case, 1 millimeter is this long. But if you look at uncalibrated one, 1 millimeter is longer than the previous one. It simply means that if we use this one and we take reading of any object, reading will be smaller than the actual, because in this case 1 millimeter is longer than actual 1 millimeter. So in this case we will get smaller readings than actual, smaller measurements. We have used this one and we got our answer is equal to 305 mm. So it simply means that the actual measurements has to be greater than 305. Actual measurement has to be greater than 305. So simply we can write down here actual measurement has to be equal to 305 plus 1%. We can say 1.0% of 305, and that will be equal to actual measurements. In this case we have 305. Now if we multiply 305 with 1 divided by 100, we will get this will be equal to 305 plus 3.05. So the actual value will be equal to 308.05 mm. So the answer is D. So D can be the answer. Our answer is D. Now we need to understand type of error. Type of error we need to understand. In this case, if we use this meter rule, all the readings will be smaller. So there will be a pattern. In systematic error, we see a pattern. So for systematic error, we can say we see a pattern. Pattern means that all the readings will be smaller than actual, or greater than actual. So then it means that there is systematic error. But if there is a random error, readings will be smaller and greater at the same time. Means some readings you will see greater than actual, some readings you will see smaller than actual. Let's try to understand this one with the help of simple diagram. Let's say this reading is the actual reading. If there is a systematic error over all measurements, all the reading will be on one side. That if there is random error, you will see some readings here and you will see some readings here. You will see on the both sides, smaller and greater. But in this case, we only get smaller. So it means this is systematic error. So the answer is D for this question. For question number 6, it is given to us the graph shows the variation with time of the acceleration of a car. Means simply we have acceleration on y-axis and we have time on x-axis. We need to find out what must the shaded area under the graph represent. Now let's look at area. Area in this case is equal to acceleration times time. But acceleration is equal to change in velocity over time times time. So time we can cancel with time. So it simply means that area is equal to delta V and this is equal to change in velocity. So the area under AT graph is representing change in velocity. Now if you look at given options, so the answer will be B. A is not answer because this is telling us average velocity of the car. This is not true all the time. So this cannot be the answer. This is telling us, C is telling us final velocity, not possible. Initial velocity, not possible. So the answer is B for this question. For question number 7, it is given to us a stone is thrown horizontally off a cliff and then lands in the sea. Air resistance can be neglected. We need to find out which statement is not correct about motion of the stone. First of all, let's get and try to visualize what is happening in this case. So imagine that this one is the cliff and one stone is placed here. So this is the sea. Now if we throw this stone from here horizontally, this stone will follow parabolic path. Mean it will go like this. Now imagine that height of the cliff. So let's say height of this cliff is equal to capital H and the horizontal displacement is equal to S. This is horizontal displacement. If we need to calculate time taken for this stone to reach the surface of water, we can consider vertical motion. If we consider only vertical motion of this stone, so the initial vertical velocity of this stone is equal to 0 because the stone is only moving horizontally. So it has no velocity along vertical. So UV is equal to 0. A will be equal to G and direction of A is downwards. And in this case, the displacement, we will take S is equal to capital H. We need to find out time. So we can calculate time taken. In order to calculate time taken, simply we can use H is equal to S and this is equal to UT plus 1/2 GT squared because acceleration is uniform in this case. And we will take downwards as positive. So this displacement is positive and displacement is equal to H. U is equal to 0. So simply we got 1/2 GT squared. From here we can say that if I write down here, we can say the time taken to reach the surface of this sea is equal to 2H divided by G. Or simply you can take root of this. So this is the time taken. For this question, it is given to us a resistance is negligible. It means horizontal component of velocity will not change. So simply we can say S will be equal to ux initial velocity times t because acceleration along horizontal is equal to 0 because there is no force acting along horizontal. So we can say ax is equal to 0. Horizontal velocity of the stone will stay constant because there is no air resistance. Look at these given options now. First option, it is given to us the final displacement of the stone depends upon its initial horizontal velocity. The final displacement means the total displacement. If you look at this one, the final displacement is this. Final displacement is this one and it has two components. So this is the final displacement. It has two components. So it has vertical component and horizontal. Then you can find out this net displacement. I can say S net. So it is depending on H and it is depending on S. So if we increase the initial horizontal velocity, mean if we increase this one, this S will increase. So S net also will increase. So the final displacement depends on initial horizontal velocity. So this one is true. This one is true, but this is not our answer because we need to find out which statement is incorrect. Now if we go to statement B, this stone travels with a constant horizontal velocity until it hits the water. This is also true because there is no acceleration along horizontal, so the horizontal component of velocity stays same. This statement is right, but this is not right option. We need to find out incorrect. Now if you go to option C, the stone travels with an increasing vertical component of velocity. This is also true because when the stone is falling down, gravity is acting on the stone. So the velocity of the stone is increasing along vertical. So vertical component of velocity is increasing due to force of gravity. So this option is also not right answer. I mean, this is not our answer because this is not incorrect. It has to be incorrect. This statement is correct. We are looking for incorrect one. So this is also not our answer. If you go to option D, it is given to us the time taken for the stone to hit the surface of the water depends on its initial horizontal velocity. But you see, time only depends on height and acceleration due to gravity. So this statement is incorrect. So the answer is D. So D is the right answer. For question number 8, it is given to us water is pumped through a hose pipe at a rate of 90 kilograms per minute. Water emerges horizontally from the hose pipe with a speed of 20 meters per second. We need to find out what is the minimum force required from a person holding the hose pipe to prevent it moving backwards. First of all, imagine that we have a hose pipe. So you can imagine this one is a hose pipe and water is coming out of this hose pipe. As water is coming out of this hose pipe, it simply means that there is force on water by pipe. Force on water by pipe. There will be reaction force on the pipe as well. So we can write down here. This will be force on pipe by water. Action and reaction forces. This question is asking us, we want this pipe to just stay here. We don't want this pipe to move backwards. We need to prevent this pipe to move backwards. So in order to stop this pipe, we have to apply force on this pipe in opposite direction of force on pipe by water. Imagine that this person is holding this pipe with one hand here and the other hand is holding like this. Now we need to find out how much force this person has to apply, and that force of course has to be equal to force on pipe by water. So we can say this is force by person. This force we need to find out, and this force has to be equal to force on pipe. So this is what question is asking us, and this is what we need to find out. In order to answer this question, we need to understand first of all what is this 90 kilograms per minute. This is mass flow rate. Mass flow rate. So simply we can write on here, this is mass flow rate. We need to calculate force applied by person. So that resultant force means force by person. Force by person has to be equal to force on pipe. Force on pipe. And that will be equal to delta P over delta T. And delta P over delta T, we can simply write down M delta V over T, or you can say delta V over delta T. So in this case, we can take V common. So we left with delta M by T. V is constant. Water is coming out with constant speed. But delta M by delta T, mass flow rate, this is delta M by delta T. So we can write down here now, we can say F force by person, we can calculate here force by person. This will be equal to V times delta M over T, or you can say delta T. Value of V we have, value of V is 20 meters per second, and delta M by delta T is the mass flow rate, that is given 90 kilograms per minute. So we can convert this one into kilograms per second. Now if we multiply these two, we can calculate value of force. This 0 we can cancel with this. This 6, if we divide this one by 3, we will get 2 here, and this one we will get 3 here. So this will be 13 here, and this 2 we can cancel with this 2. So we simply left with 30 Newton. So this is the force applied by person, and this force is also equal to the force on pipe but in opposite direction, and this force is also equal to force on water by pipe. So this is how you can calculate force applied by person. So this is the answer. This is kind of typical question. You need to understand resultant force is equal to rate of change of moment. For question number 9, it is given to us a skydiver leaves a stationary balloon and falls vertically through a long distance. Which graph best represents the variation of the acceleration of the skydiver with distance traveled as she falls through the air? Imagine that skydiver is a ball. So we can imagine that this is skydiver. At the beginning, initially, the force acting on the skydiver is only equal to mg. So we can say net force on skydiver, F net, is equal to mg. F net is equal to mg, so simply we can say ma is equal to mg. So the initial acceleration of skydiver is equal to g. But when this skydiver will fall through air, skydiver will hit air particles, and air particles will hit this skydiver back. Skydiver will apply force down and air particles will apply force in upward direction. So there will be air resistance. Imagine that when the skydiver is here, there are two forces acting on this skydiver. One is the weight that is acting down and other one is the air resistance. Air resistance is acting upwards. These two forces are not balanced. It simply means that skydiver has acceleration that is downwards. That the resultant force has been decreased. It means acceleration, we can say this is A1. So the A1 will be less than G. Finally, these two forces will be balanced. Imagine that when the skydiver is here, weight is acting down and the force acting upwards. This force is air resistance and these two forces are balanced. When the forces are balanced, acceleration will be equal to 0. From here simply we can see as distance is increasing means skydiver travel more and more distance, acceleration is decreasing with distance. If you look at C is not possible. This is telling us acceleration is constant, so this is not possible. This is telling us acceleration is increasing with distance, so this is also wrong. This is telling us acceleration is increasing with distance. This is wrong. Acceleration is decreasing with distance. And finally, at this point, acceleration is equal to 0. And initial acceleration will be equal to g. So our answer for this question is A. For question number 10, it is given to us the diagram shows two spheres approaching each other head on. Each sphere has speed u, one sphere has mass 2m and other has mass m. Which diagram shows the result of perfectly elastic collision? So we need to understand what is perfectly elastic collision. Perfectly elastic collision means that kinetic energy before collision is equal to kinetic energy after collision. Or we can say that relative speed of approach is equal to relative speed of separation. For this question, we will use relative speed of approach is equal to relative speed of separation. We will use this concept and we will answer this problem. If you look at these two spheres, we can calculate the relative speed of approach. So I will write down V approach is equal to U and they're moving in opposite directions. So the relative speed of approach is equal to 2U. Now we need to find out which two spheres they have the same relative speed of separation. Now in this case, you see these two spheres, they are moving in opposite directions. So if we need to calculate the speed of separation, means relative speed of separation, simply we need to add these two together. Means we need to add their speeds. So we can write down the speed of separation simply will be equal to u by 3 plus 5u by 3. Now if we add these two, we will get 6u by 3 and this is equal to 2u. So they have the same relative speed of separation as relative speed of approach of these two spheres. So they have the same relative speed of separation. So it means A is the right option. Means this is the correct answer. But if you look at B, in this case we can also calculate relative speed of separation. We can also find out as these two spheres, they are moving in opposite direction, they're moving away from each other. So simply we need to add their speeds. So we can say u by 6 plus 2u by 3. In this case, we can take LCM 6. So we have u here and here we will get 4u. So the relative speed of separation is 5u by 6. So this is not correct option. Now if you look at C, we can also find out relative speed of separation. As they're moving in the same direction, so the relative speed of separation we have to subtract. So 2u by 3 minus u by 6. So we can calculate the relative speed of separation. So if we take LCM is 6, so we will get 4u minus u and we will get 3u by 6, or simply we can say this is equal to 1 by 2u. In this case, they stick together, so the relative speed of separation is equal to 0. They stick together. So the answer for this question is A. You need to understand how to calculate relative speed of approach and relative speed of separation.